Hello everyone, this is Hassan Najafi from Akam CA Group. In this tutorial, I want to show you how to create a multi-zone mesh using a block technique in a tube. Here in this tutorial, we have a tube which the phalloid fellow, we want to simulate the phalloid fellow within the tube, and also we want to consider the tube thickness as a solid material around the phalloid regime. So let's go, and we're gonna use the ICM CFD software for this tutorial. Let's go. As always, I already provide a working directory, as you can see here. So first of all, we need to save the project as a project 2. At this time, I will consider it as a project 2. So save. The next step is to just create a 0 point. We want to create the geometry, and then we will create the mesh. For creating the geometry, first I create a point, as you can see here. From geometry, create point and 0, and then I need to specify the unit. I want to use millimeter here. Okay, and this is the millimeter, as you can see. For the creating the geometry, first we need to create the points and then lines and surface. So let's do it for inlet side of the tube. Let's say we're gonna have a tube with 20 millimeter in diameter. So x should be 0, y x should be 10, y 0, and z 0. Apply. If you want to see the other things happened in the view, for example, right now I applied a new point, but I cannot see that point. So you need to go there and click on fit window. Here, another one, and also we need another one here. So here you can see this is the middle point. This is the 2 point that we can create a circle in this plane, in the XY plane. Just for informing how to work with ICM CFD, if you want to zoom in and zoom out, you just need to roll down the screw, and if you want to rotate, you can use right click of the mouse, and if you want to rotate in all direction, you can use the left click of your mouse. And if you want to change the view, just go to the view tab and click, let's say, front. Okay, as I told you, we're gonna simulate the tube material. I mean, we want to consider a tube material in our simulation. So let's say we're gonna have just a tube with 2 millimeter. So I just put 12 here. So this is gonna be a thickness of our tube. Another one, 12. Okay, so this is the inlet, but actually our tube has an outlet. So the tube length, I consider it as a 200 millimeter, 20 centimeter. So let's do the same things that I done over there. So 10 millimeter here, 0, yes, 12, and here 12. So here we created the points. The next step is to create the curves. If you check here, there is a tree here. Right now we just have point. You can select and deselect these points here in order to see. I mean visible. I mean showing the points or hide them. So the next step is to create a circle. Here, when you click on the curve or modify tab and circle, you need to the software will ask you to select 3 locations. So we need to select 3 points, the points that I created there. I want to zoom into the inlet part, then select it. the first point should be the center one, and the next 2 points should be the other 2 points in a circle. So here you can see the circle. Now if you can see here, it says that if you click on the left button you can select the new points, but if you click on the right, it means cancel. Now we gonna make the next circle here. Just select this one, and this one. When you select it, some comments ask you to click on the middle button of your mouse to done the action. Now we don't have it, and we don't need this. So this is the 2 circles that I created there. Let's make the other 2 circles. Okay, here. Also we need a line, because next step we want to create the surface, and here you go. For creating the surface, it's easy. You just need to click the 2 point and click on the middle point to done the process to create the lines. So here you already created the points and curves, and here you can see the points and curves that you can hide them. The next step is to create the surface. Here the simple surface, I'm gonna use a simple surface and click into the first curve, as you can see here, and when I select the curves, I click on the middle button, and then here you can see the surface. I right click on the mouse to cancel the process. Just I want to show you how to see the surface. Right now it's appear as a wireframe. You can right click on the surface and click as a solid if you would like to see it as a solid. So let's go and create the other surface. I want to have a surface here. This is a thickness of our pipe or tube. I just need to select these 2 lines and click on the middle button. So here you can see another surface is already generated. The next step is to the creating surface along the tube. So I can use this one, swept surface, or this one. So I prefer to choose this. I select first the curve, and then the software will ask you select the driven curves like this one, and OK. When you click on the OK, and if you active the surface, you will see the surface is created. Just one more time for the other curve, and let me do it again here, and then next curve. So OK, you can see this is a 2 surface. If you want to delete any surface, you can use here surface delete, delete curve, delete point. I just want to tell you about this. Right now you can delete it or redo the previous process. The next step is to create a surface for the outlets. I just click here and here. Let me redo it. Disable the surfaces in order to see the better feature. Okay, I made a mistake. I selected the wrong action or wrong button. So need to choose a simple surface. Just this one. Okay. Now let me do it again. The bad things about this software, it's better to not redo your simulation. Actually, redo the process. Let's do it again. Click the surface, simple surface. I can just show it as a wireframe in order to select appropriate. Even I can hide the surfaces and middle button. Okay, I guess it's done. Great. Let's do for another one. I zoom in order to see the curves very properly. Then select. Just deselect the surfaces. To surface, middle button, right click. So here you go. Now we have all the surfaces that we need. Actually, we also, I'm not sure if I created the inner surface. So let's first name the, I guess I didn't create it. Let me see. I guess no, I didn't. So let's name the surfaces, name the geometries parameters, and then we will check it again. Okay, so this is the wall of the tube. So in order to name the surfaces, because the name that you gave in this stage, it will be your boundary condition name in the solver, Ansys Fluent or CFX or any software that you are gonna use. So I will click on the create part. I will call it as a wall. So I will select this one, and now I can hide it. So it's good. I already created. Sorry, I forgot this one. We also have an interface here. Interface. Okay. So here the interface. I hide this one as well. Create part. Inlet. We have an inlet, let's say velocity. Okay, right now I click there and I choose a point. If you want to choose any parameters from a complex geometry in the future, you can deselect the parameters that you don't want to select, like point, curves, and body. I just want to select the surface, so I click on here and then I click it. This is the inlet velocity. So let's name the outlet. I just click as a outlet and select this surface. This is the outlet, and it was a inlet velocity. So we have two sidewall. I can say I just name it as a side wall or wall side. It's better. Whatever you need, just -1. Right click to disable the process, and because this is very important step, wall side -2. Here you go. So now we just name the surfaces. We have some leftover geometry, I can say, points and curves. Let's assign them to the selective or associated names. Okay, for the inlet velocity here, I add to part. I want to add points and curves in this stage. In this step, sorry, add to part outlet, and here wall side. Just right click on the wall side, add to parts. So these two, and let's add these two as well. And for wall side 2, add to parts, and this two. Okay, and this. For in wall, we can add this, and the other edge, it's for I mean the other curve is for interface. So here we finish the whole things. This is the inlet velocity, sidewall 1, sidewall 2, outlet, while the interface in our geometry, and that's it. Just I want to save up to this step, save project as project 2. So let's go to the working directory because I want to show you something. In ICM CFD software, we have many different type of the files. For example, here we have PRJ, but in order to see it, you need to file name extension, you need to activate this one. Anyway, we have a PRJ and TIN. PRJ is a project file, and TIN is a geometry file. If someone asks you to give the geometry, you can just share this one. Okay, so the next step is to create the block, because we already created the mesh. And also I forgot to telling about you, this is the some specification and parameters that we have during the generation of the geometry, and another file will be added as a block parameters. Okay, let's go to create the block. First step is to go into the blocking tab and click on the create block. Here you can name the zone name. I mean, you can call it as a water or as a solid or tube or anything, but I want to name it as a zone. I suggest you do not use the fluid and solid, because I want to, at the next step in the Ansys Fluent, I want to create the interface, coupled thermal interface automatically with the software. So I just name it as a zone 1 and zone 2. Because I want to create the block in the whole tube. I name it as a zone 2, and I want to have a zone 1 in tube. I mean inside the tube. It means water. So I just name it as a zone 2, and in the type I will select the 3D. Even you can select any name. So then I click on the select geometry. Here you can select from the screen, or you can select this one, select all appropriate object, and here you go. You can see the block. You need to press right click of your mouse to disable the action. So here you go, you can see the block around the tube. The next step is to create some points around the tube, because in block technique we need to associate the edge to the point, the edge to the curves, and the vertices to the points, because you know the name is differences. In geometry we can say this is the point, this is the curve, and we have surface. But in the block we call this plus sign as a vertex, and this one as a edge. So we need to associate the edge to the curve and the vertex to point. To do that, we need some points on the geometry in order to have a high quality block. Let's do it. I will go to the geometry and create some point, but I don't have the exact direction, exact value of the dimension XYZ for the points. So I wanna use another way to create the points. Here you can see the parameter along a curve. I click on this. This means that here we have a curve, and if you divide the curve from 0 to 1, based off the value that you give here, it will create the points. So for example, from here to here is 0.5, here would be 0.25. The middle of this space will be 0.125. So I just select 0.125. 1 2 5 here, and select this one. You can see the point is created here. Select the other curves here and here. The next point will be 0.375. I just need to add 0.125, excuse me, 0.25 to the previous value. Here, it's very easy. The next one, 0.625. The next one will be 0.875. Okay, now if you want to check the point is created appropriately, you can select view and you can change the view here. So I select front, and you can see everything is perfect. So let's go do the association here. After you in blocking tab, you can see associate here. Let's create associate the parameters. You need to select associate vertex because we want to do this one at the first time. This is the zone 1 if I'm not mistaken. Okay, just click this one. Okay, the geo also disappear here. It's good. This is zone 2, excuse me, zone 2. Okay, let's do it. In order to associate point, vertex to point, we will do right this. First we select the vertex and then point. When you do that, when the vertex associate to the points, you can see that plus sign, the color of it change from black to red. Here I just do it very fast. Okay, great. So I just check if everything is okay. Okay, everything is okay. So as you can see here, this is the block for zone 2, but we also have another zone which is the domain inside the tube. We need to make it. But in this tutorial, if you just select associate, set up the points or elements to the edge, you will have a mesh. But the problem is that this mesh is not appropriate. So we need to create the O-grid. I already provided a video about this and also a page in our website to explain the differences between different type of the O-grid. You can check over there. So let's go continue our work. I don't want to do another show you a mesh right here, because in another video I already showed how what's happened if we don't have O-grid. Let's do the associate for edge. Here you can see, select the associate and associate edge. In this step, the software asks you select the edge, so you should select the edge in order, and after select the curve. I select the curve and I click. When I want to finish, when I finish my selection, I click on the middle of the mouse and then everything's done. Right click to cancel. Middle, it means done, and right click or backup or cancel. Now because it's already associated, so I click on the right button and then everything is fine. Let's do it for the other part. Okay, everything's fine. Even if you open the blocking tree and right click on the edge, you can active show association, and here you can see some arrows which shows that those edges are associated. For these other edges, we don't need to do an association because the geometry is very simple and it's already created without any problem. Okay, let's go, and right now we just have a one block. Even if you active the block and show it as a solid, here you can see just one block. Let's create another block, and before that we need to create OGrid. In order to do that, go to the split block and select OGrid block, and here you should select the block, and then you need to select some faces. These are the faces that we want to create OGrid from, let's say from inlet to outlet. So we select these two faces in inlet and outlet. Then you selected them, you need to click on the middle of the button of your mouse. Here you go. And after that you need to set the offset for the distance between here and the middle square block. For this one I put 8. If you this is the value that should be from 0 to 1. The less value that you selected, the less distance you will have between this point, this part to this part, the middle point. So then I just did that, and OK, click OK, and here you go, you can see the OGrid in the middle of your tube, and if you active the block you will see there are some other blocks that are already generated. Okay, but this is still just one zone. Okay, and all of them is in the tube, in the whole geometry tube, but we need to create a zone for the tubes and for Fluent. In order to do that, we need to split this edge. So we will go to the split block, and here you can see the split block by already visible. And now software asks us to select an edge. I will select an edge here, and even you can move it a little close to the point by holding it, but here is okay for me. And then I click on the middle button, and this is done, and right click, cancel. So now you can see new edges and new vertices. We need to associate them as well. Let's do it very quick. And also we need to associate the edge to the inner curve. It's very easy. Going to the next part and do it again. This is belongs to the interface, actually, I can say. Right click to cancel. In order, just be sure that you select the edge in order and then curve. Okay, because this is an OGrid, we don't need to what it called associate it. It's okay. Here you go. Now we done all the setup and setting, and but one more thing is that we still have one zone. So I active the block. If I change the view, you can see these blocks supposed to be the tube block, and these blocks supposed to be the Fluent block or region block, the one that Fluent wanna calculate it. I mean laminar or turbulence or whatever. So we need to do something. We need to select a new zone. In order to do that, I will go right click on the parts, create parts. This is just like the way we select the names or assign the names, but at this time we need to select block material. And also before that we need to set a name. I name it as a zone 1, and then click this one. So we need to select, okay, I zoom in, select these blocks, okay, and middle, button, right click, cancel. Now if you disable the zone 2, you will see we have a zone 1 and zone 2. Okay, this part is done. The next step is to assign or set the element to the edge. Let's do it. Just going to the blocking tab, pre-mesh params, and select this one, edge params, and just click here and select one of the edges. So we don't want to waste time to select each edge. There is option here called copy parameters to all parallel edge. Here you go, and then 2.0, because I would like to have a 1 millimeter element, I just put 201 nodes here. You can see the space as 1 millimeter. Click apply. Here I would like to have 21 in order to, okay, this one is good in order to have elements around 0.5. 21 here, and here I can have let's say 4 or 5 is enough, and here is let's take it 5 to see 0.5. Let's make it 10. I guess 9 is okay. Click on apply and okay. Now after we set the element to the edge, let's get a pre-mesh and see the results. In order to see the good quality, I right click on pre-mesh and select solid and wire, view front. Here you go. Disable the edge. This is a pre-mesh that you can see here. Let's make more elements here. 5. So here the final mesh, pre-mesh actually we have, and if we want to check the quality, we can check here pre-mesh quality histogram and go into the quality section and apply. And you will see here that the quality is more than 0.7. Right click on it and done. Okay, so at this stage we created the mesh as you can see here, and the next step is to export this mesh to the MSH file, which I want to use that mesh file for in Ansys Fluent. In order to do this, we need to first save the project. So I did the project, and as you can see here, this is the parameter of blocks that's already saved in the working directory. Then we go into the blocking tab and save on structure mesh. You need to do this. Just name it as a project 2. You need to do this because here we have a structure mesh, but this software, in order to create the mesh file for Ansys Fluent, it needed an unstructured mesh, and this is something is in the code, not in the showing or in the view. So don't worry about this. Here you can see the unstructured mesh file, I can say this, and then we will go to the output and go in there, select Ansys Fluent is already selected, and click on the right input. It asks you to save the project, and then here the software asks us to show it or open the unstructured file, and after that this window is come, we should select 3D because the geometry and the mesh is 3D. If you want to do any scale, you can do it right here. And this is the file, the output file. I just keep it as a Fluent file. So here the Fluent MSH file. At this point we created the mesh file which is suitable for Ansys Fluent, and let's launch the Ansys Fluent to see if the mesh is works. So here the Ansys Fluent, I select 3D because it's 3D active double precision, because if you want to do the turbulence flow simulation, you definitely should have dense mesh, and you had high aspect ratio in your mesh, so you need to activate. Here the working directory that's I already had, let's copy it and OK. Now we assume that we created this geometry for a laminar flow simulation. Let's read the mesh file, Fluent, OK. Here we have the mesh. Even if you go to the scale, you will see it's from 0 to 200 meter. You need to scale it, so we can convert unit by selecting this one. Here I says that the mesh was created in millimeter, so here the scale that we need, and we need just click on the scale, and here the suitable scale that you can see here. If you already created your mesh in meter unit, you don't have to do this scale. Okay, so this is the inlet velocity, outlet, interface, and the walls. Before doing anything else, I need to check the mesh, which shows that the volume is not negative, and here it says that there is an interface which has two adjacent cell zone. I know it because we still didn't select any interface in this Ansys case. Then we can select the report quality, and here the quality, which is very good, it's almost 0.8. I need to create the energy because I want to have a thermally coupled interface. And when you go to the cell zone condition, you will see that the zone 1 and zone 2, both of them is in the fluid type. And here, if you see, you can see the software already selected inlet velocity as a velocity inlet, interface as an interface. This is the interior, and outlet vent is it doesn't important. You can put it as a pressure outlet, and the walls. So it's okay. But when you change the zone, I mean we already assume that the zone 1 is the fluid. Okay, so zone 1 is a fluid, but zone 2 is a solid. When you active this one, the Ansys Fluent software automatically created the interface. Here you can see two interface as a wall, and if you open it, you can see that it's already thermally coupled. So this is one of the methods, the automatic methods, that in another video I already explained 3 methods about creating multi-zone mesh. This is one of the automatic methods that I already explained there. You can go and check. I put the links in the description and here for your further action. And if you see this one, the interface shadow is also thermally coupled. So this shows that our mesh is perfect. There is no any problem here. And just for your information, if you want to have a turbulent regime, you can change the element here. As you can see here, you can select a specific space, let's say 0.01 and the ratio of 0.2, and click apply, and just create it again. And you can see here there is a more dense mesh over there. Even I need to increase the number of the elements here. Apply. Okay, here you can have many dense mesh near to the walls in order to see the boundary condition. And the first space is depends to the turbulence regime, the Reynolds number of your model. And even here we have many options, like we have exponential 1. If you select this one, just check how is it works. So, and also we have a SP line, which is a very good way. It will gives you many options. Let's say 0.01 for the set first element high, and let's increase the number of element to 40. And just when you click on this every part, a point will be created, and then you can move it to in order to have a logarithmic ratio. As you can see here, it gives you very good options to create your elements for your boundary layer. Here, this is the one that I created. Actually, it still needs further improvements. This is so big, I guess. Now it's perfect. Okay. You can do it later as a practice. Okay, so now here you saw how to create the multi-zone mesh using block technique and ICM CFD. Thank you for your attention. Please don't forget to support my YouTube channel and subscribe my YouTube channel.